Hello, I'm Nate Walker from EOC, and I worked with Laura Jones at Middle School to prepare this presentation. We're going to give you a presentation on performance tasks. From this presentation, you should get information about how to gather some and how to implement them into your classroom. Um, This is a slide that we were actually going to use in the presentation called Sharing Gasoline Costs. If you're having trouble reading this, please go ahead and get a hold of the file that I should be able to provide to you where you might be able to locate this presentation. And if you're unable to do so, then just email me at nwalker@rusd.k12.ca.us and I will be able to get you that file so that you can actually practice or try this. It's also a Mars task that you'll be able to get to, so you could actually just go to the Mars website, which at the end of this presentation I'll kind of click through some of those resources. So at this time, go ahead and pause the video and you can work on this task. Okay, so because you're more than likely watching this video, you probably will not have any partners that you're doing this with. But if you do, then go ahead and take some time to kind of discuss how you solve the problem, or just kind of think about the multiple different ways that that problem could be done. In the Mars tasks, and this sharing gasoline costs is a Mars task, they're very scripted. They have a lot of information that you can get, and they have what are called samples, on some of them, sample student responses. And in this case, we're going to go through two of them, where one is for Donna and the other one's for Kimberly. And they kind of walk through how students solve the problem, and then also sometimes gives kind of leading questions for students to actually look at the like this sample student response and kind of engage in that discussion as to, well, did they do it right? Is there a better way they could have done it? And so on. And like kind of like the last problem there, is there anything that Donna could have done to improve her work? And in this case, Donna solved the problem by using an algebraic method of setting up a cost per block. In the next one, Kimberly kind of broke it down and she kind of figured out, okay, how much it costs per block, and notice her cost per block is different than Donna's. And she kind of breaks it down by each person as for how long they've traveled in the car, and she kind of chunks it according to first two blocks of Laura is $30. Next three blocks is Laura and Chin. Next three blocks is Laura, Chin, and Jason, and so on. So the total dollar amounts are actually very different, but in this particular case. Now, what you may have done to solve the problem was more than likely use the proportional way of doing it, which was allocating how many total blocks and then how many blocks each person was in the car for, and then solving it proportionally for the total gas costs. Now, the whole purpose of this task is that we can figure out a way to find out what's fair. And in the real world, and many times we have situations and circumstances and problems that we come across that there are many different ways to solve. And that's kind of like the key components of like a performance task, is that it's not just always one answer, but they're actually varied, where we can potentially have multiple answers, and then you can actually kind of spark a debate about which way is the right way of answering the problem, which way is more efficient, and so on. So a few misconceptions that hopefully will be cleared up for you is that performance tasks don't always have to be a formal assessment. They can be used to just introduce or practice or informally assess a concept. Because the purpose of performance tasks are kind of, as we'll kind of get into in a little bit, is to really use math in kind of a unique way and take those concepts and those conceptual understanding that you have and apply it to an application or a real-world problem. And a big misconception is that performance tasks are these long, drawn-out problems that have a lot of inner working pieces to it, and they don't have to be. They can be as short as less than a whole period, or as long as a few days if you want to have one of the long performance tasks. Okay. So, just kind of to get a general sense, this is not an end-all be-all for what is in a performance task, but these are some pretty common themes that kind of run across all of them that you'll see. Most apply mathematical concepts to a novel situation, like I was saying before about real-world situations. And they have many different entry points and methods of solutions, so there's not just one way to solve the problem. And what you'll find here is that sometimes when you're doing performance tasks, where we all have in our classrooms where we have maybe high-level students and lower-level students, you might actually find with using performance tasks, some of the lower-level students have a better entry point into the problem because they kind of think differently than some of the higher-level students. And the higher-level students might have trouble with the performance tasks because they're so used to just seeing something done, copying it, and regurgitating it. Also, performance tasks tend to be open-ended and have more than one answer. Kind of like I said before, they have methods of solutions, and they may have many different answers. It's very similar to the sharing costs, or the sharing gasoline costs, where depending on the way you did it, you might have one particular answer or another way, and in some cases you could do 2 or 3 different methods and come up with the same. Now, another common theme is communication and defending your answers, either verbally or in writing. So for the verbal aspect, you could have a whole class discussion, or you can use peer-to-peer, or you can have them just in writing explain in detail why they chose the method of solution, why they picked the information they did to solve their problems. So again, these are not all of the things that are involved in a performance task that make up a performance task, but these are some of the most common threads amongst them all. And now we're going to take an example of a performance task from Dan Meyer. So he created what are called these 3-act tasks, where Act 1 kind of hooks the student in with a picture, a video, or an intriguing idea. Typically, the Act 1 elicits curiosity and questions from students that they're using their sense of wonder to try to find an answer to something. So we're going to take a look at a video for this, and you can go ahead and pause the video and watch this on YouTube. It's Dan Meyer 3-act math hot coffee, and it's just an interesting video that kind of gives insight about stuff. So check it out. Alright, welcome back, and now we're going to kind of use that and segue into Act 2, which during this time we're going to use the teacher to determine what kind of questions we want to take students to get to, or where we want them to go. And in this case, we want them to kind of eventually solve a volume problem regarding how much liquid is in that coffee cup. So during this time, we'll also have students ask questions. Teachers, you'll typically either write them down or listen to them, and we're trying to get them directed towards the questions we want to be answered, but none of the questions that students ask are bad. We're trying to take in every single potential question because that's where we get the most involvement and engagement from the students. Because regardless of how high a level of math you are or how low, everyone can have questions and curiosity. So once we determine and we kind of get the questions, we gather them together and say, okay, well, we really want to focus in on these 2. And in this particular case, we're going to focus in on the size of the cup and then also how fast it's filling in order to figure out how many gallons it takes. So students ask questions to get the information they need in order to solve the problem. So at this point, we only give them crumbs of information. We don't give them everything that they need in order to solve the problem. And we really only give them the information after they deem that it's necessary and they ask for it specifically. So in this case, we're kind of hoping that eventually, if we're trying to get to how big the cup is and how fast it's filling up, then we kind of need to know two solid pieces of information, which I've already actually loaded onto the next slides. And the one is, how big is the cup? Well, it's 7 feet wide by 7 feet tall. And then it's also filling up with two machines, each pouring out 2.1 gallons of coffee per minute. So that is also important to note, is that there are two machines, not just one hose filling up the tank. So a valid question was like, how long does it take to fill up the tank or the cup? Now in Act 3, this is where the visual solution to the task comes out. We show a video or show a picture of that beginning part with Act 1, and then in Act 3 is like the culmination of it. Usually during this time, students are more engaged because they've kind of derived their own answers, they've been involved in the process, they've come up with their questions, they've gotten their answers, now they want to see if they're right. And usually students will kind of create that competition amongst themselves to kind of figure out, well, whether they were closer or he was closer or whether she was closer. So Act 3 is very useful and just exciting. So during this time, go ahead and pause the video and go to YouTube go to Dan Meyer Hot Coffee Act 3 and then watch the video there. So you can go ahead and pause now. Alright, thanks for coming back. Now, as you can see, that cup held a whole lot of coffee. Probably more than you were maybe necessarily expecting. I know for me that it was a lot more than I was thinking. I was thinking maybe about 1,000 gallons, but I was way off. So now we'll take a look at some of the resources for performance tasks. On the left-hand side, you have structured resources. These are websites that are like where they have information that is put together. Their performance tasks are really tight, focused, a lot more detail in how to implement them in your classroom, how to do them, how to go through them. The Mars tasks is very, very detailed. The other ones, Illustrative Math, has a little less detail, but still very informative of how to do it, and they're really kind of engaging, interesting style of questions. The Common Core Better Lesson, Math Snacks, and Emergent Math are all very similar to the Illustrative Math. I would say the Mars tasks are a step above all of them, because sometimes they can be really involved, but the other ones might be more for a little less, maybe like a one-day kind of thing. Now, it doesn't mean that the Mars tasks are just way better. It's just, as a teacher, when you're new to performance tasks, kind of looking at the Mars tasks will kind of help you get a better sense of, okay, well, that's why this is going on here. And they walk you through, like, as a teacher, what you should be thinking about, and as the students, what the students should be doing, so that you can get a good idea about how this performance task really comes out and when you implement it in your classroom. Then we also have unstructured resources on the right hand side over here. This is where you have, me and Laura decided that these are resources that don't have the same type of structure or as much detail as the structured resources. They just kind of give you information. They say, here, boom, here's a lesson. They don't tell you how to do it. They might give you some resources, in the case of Dan Myers, where they might give you the videos, but they don't tell you how to do it for yourself. So you get to decide how to do that. Andrew Stadel and Robert Kaplinski's are very similar. The 101 Questions is a website that has like just visual, either video, like short, brief videos or pictures that elicit questions. And the idea is that people are supposed to just spout out questions to these videos or these pictures, and then the idea is to take some of those questions and try to find the solution for them. Graphing stories is very useful, and that it's for learning how to graph some functions, that they get a nice sense of everything is in versus time, so they have something going on versus time to where the time is actually marked on the video, so they're able to see a timing, and you're going to be graphing a particular case. There's one that is graphing the distance of an airplane, of a paper airplane, from the height off the ground versus the time of the video. So it's actually has some interesting graphs to kind of derive, and then you, as a teacher and students, you can kind of talk about, okay, well, when this is happening, how does that occur? And then using that, you can create lessons from that. And then we also have what's last are like web blogs. These are just 3 of the teachers that have a lot of really interesting stuff on their site. Dan Meyer, Fawn Nguyen, and Matt Vaudry. And all 3 of these also are kind of linked into like what's kind of new in the last few years, is this kind of math blogosphere, so to speak, where Dan Meyer has on the right-hand side of his site a whole bunch of other teachers that he has links to, so that you can go, that's an interesting, I'll check that person out, and then boom, you're now on a different web blog, and that teacher also has a bunch of lessons that they talk about and share, and they get thoughts on, and a bunch of these teachers interact with each other, and then so you could actually, if you wanted, set up your own web blog and also start to work towards being involved in that community as well. And there's a lot of just really good ideas bouncing around out there. Unfortunately, they're not always put together in the best way to the resources on the left-hand side, the structured resources. But they can still be good, and as a new teacher that you're doing performance tasks for the first time, maybe stick to the structured resources. Or if you're really kind of more ambitious and you're very creative and you're really good at creative stuff on your own, maybe get ideas from the structured, tweak it, do whatever you want to do with that task. Maybe take the concept and do it yourself in a different way, or take some of those unstructured resources and use those ideas in your own way and manipulate them to fit your needs and your students. So I hope that you've gotten everything that you've needed about performance tasks, and if you have any other questions, please feel free to email me. I stated my email earlier, but I'll go ahead and say it again. It's nwalker@rusd.k12.ca.us. And have a good day.